let's be real for a second. Are delayed lead times and bad sourcing decisions quietly killing your manufacturing efficiency? Because in today's global metal fabrication ecosystem, efficiency isn't just a nice-to-have goal anymore. It is literally the absolute baseline for survival. As we navigate this incredibly high-stakes landscape of 2026 manufacturing, picking the wrong metal cutting technology can absolutely destroy your profit margins, well before your product even leaves the factory floor.
So, welcome to this explainer. Today, we're on a mission to completely demystify material compatibility. We're going to compare two absolute industrial heavyweights and ultimately help you optimize your supply chain costs. Look, whether you're a procurement pro sourcing components globally, or maybe a brand owner looking to invest in your very own cutting tables, getting this right is just non-negotiable.
Here's our quick tale of the tape for today. We'll be looking at the great metal debate, material compatibility, thickness and precision, total cost of ownership, and finally, matching the buyer to the technology. All right, let's jump in.
Number 1. The great metal debate. 2. Legacy titans of fabrication. Okay, so for decades, the fundamental debate in metal fabrication has really centered on plasma versus flame cutting, which is also known as oxy-fuel cutting. But as we move deep into 2026, the massive shift toward automation, AI-driven CNC controllers, and just way higher precision requirements, it's completely altered the cost-benefit analysis between these two legacy technologies. But before we compare them side by side, we actually need to understand a totally crucial concept. It's called the heat-affected zone, or HAZ. See, when you cut metal with extreme heat, the edges undergo structural changes. Now, why does this matter to your wallet? Well, because reducing this heat-affected zone is basically the holy grail of saving money. If your cut leaves a massive HAZ, your lead time is going to get absolutely crushed by secondary processing, stuff like grinding or deburring. Minimizing that HAZ means your parts are ready for immediate welding or powder coating, which slashes the labor hours billed by the factory.
Moving on to part 2, material compatibility, or the physics explained simply.
You know, understanding how these machines actually cut on a physical level is the real secret to choosing the right supplier. Let's use a really simple analogy here. Think of flame cutting or oxy-fuel as accelerated rusting on steroids. It relies on a chemical reaction, specifically oxidation, to literally burn away the metal. And because it relies on the specific chemical reaction, it basically only works well with carbon steel and low alloy steels. On the flip side, we have plasma cutting. Think of plasma as a lightning bolt slicing through butter. It doesn't rely on chemical oxidation at all. Instead, it uses a superheated ionized gas to just melt the metal and blow it right away. It's pure concentrated electrical energy. And because plasma acts like that ionized lightning bolt we just talked about, it can cut absolutely any conductive metal. Stainless steel? Yes. Aluminum? Yes. Copper and mild steel? Absolutely. For multi-category sourcing, this kind of material versatility is absolutely critical. It means you can source stainless steel brackets, aluminum automotive parts, and copper components all from one single supplier using one high-end plasma table. No need for them to change their entire machine setup. This kind of agile consolidation drastically reduces your logistics complexity. It's a game changer. Okay, part 3, thickness and precision, the tale of the tape. Right, so now that we know what materials we can cut, we really need to look at how thick we can cut them, and of course, how accurately. The contrast in capabilities here is honestly pretty staggering. Plasma has an ideal thickness sweet spot right between 0.5 millimeters and 50 millimeters, though to be fair, high-definition plasma can push up to 80 millimeters. It's extremely fast on these thin to medium materials and offers a really high-precision edge with a very small kerf, which is just the cut width. But then, look at flame cutting. Once material exceeds 50 millimeters, plasma's efficiency just drops off. Flame cutting, however, it asserts absolute dominance in heavy industry. I mean, it can easily slice through 200 or even 300 millimeter heavy industrial steel plates. While it is slower and does require preheating, it offers a cleaner, more vertical edge on those extreme thicknesses than plasma ever really could. There's also a highly specific but totally vital advantage to flame cutting that often gets overlooked. Think of it as a bit of an insider secret. If your sourcing involves on-site fabrication, say remote installations or repairs out in the oil and gas sector, flame cutting wins easily. Why? Well, because oxy-fuel torches require absolutely zero electricity. None. They run purely on pressurized gas cylinders. When you're operating out in remote field locations where the power grid is either completely absent or super unreliable, this extreme portability makes flame cutting just an indispensable tool. Which brings us to part 4.
total cost of ownership, looking beyond the initial unit price. Look, picking the absolute cheapest initial unit price on a quote is a huge rookie mistake. It completely ignores all those hidden manufacturing variables that can and definitely will blow up your procurement budget. So let's walk through these hidden costs systematically. First up, gas costs. Flame cutting consumes really high volumes of oxygen and fuel gas. In regions with volatile gas prices, suppliers are going to quietly bake fuel surcharges right into your bill that you definitely didn't see on that initial quote. Second is the consumable life cycle. Plasma requires frequent replacement of nozzles and electrodes. If your factory has poor maintenance schedules, you are going to face massive downtime and severe lead time delays. Third, electricity consumption. Plasma tables are incredibly power hungry. If your supplier's in a country with high industrial electricity rates, guess what? That overhead gets passed directly to you. And finally, labor intensiveness. Flame cutting is just fundamentally slower. If you have an order of 10,000 units, the sheer number of machine hours billed for flame cutting might far exceed plasma, potentially making the so-called expensive plasma option actually cheaper when you buy in volume.
All right, our final section, part 5, matching the buyer to the technology. Which one actually fits your business? So the crucial takeaway here is applying everything we've just learned directly to your specific supply chain, because choosing between these technologies depends entirely on your buyer profile. Let's try and match you to the perfect setup, okay? If you're an e-commerce seller sourcing customized decorative metal panels, shelving, or maybe small mechanical parts, plasma cutting is your undisputed winner. Its multi-metal versatility and clean finish mean you can go from a prototype to Amazon ready incredibly fast. However, quick pro tip for you here, always ask your supplier for a nesting report from their CNC plasma software. This just ensures their layout is actually efficient and you aren't accidentally paying for a bunch of excessive material waste. Now, what if you're an OEM? For original equipment manufacturer brand owners developing proprietary hardware, your target should be 2026 AI-driven high-definition plasma. It actually rivals traditional 10-kilowatt fiber laser quality for materials over 12 millimeters, but at a fraction of the cost. This gives you those really tight tolerances you need for global assembly, but you gotta be warned. You must verify the age of your supplier's consumables. Worn-out plasma nozzles will lead to completely unacceptable edge rounding, so always request a sample cut of your most complex geometry first, just to test their machine's calibration. Finally, if you're a bulk buyer importing thousands of tons of heavy structural steel for construction or shipping, flame cutting combined with multi-torch systems is absolutely your most cost-effective path. It handles heavy tonnage brilliantly, but, listen closely, you must aggressively negotiate slag management in your contract. Flame cutting produces a ton of dross, or slag waste. You have to ensure the supplier removes the slag before shipping, otherwise you will literally be paying heavy freight costs just to ship useless waste across the entire ocean. No one wants that. Regardless of which buyer profile fits you best, you really need to adapt your quality control checklist directly to the physics of the technology you just selected. So, during your pre-shipment inspection, make sure to check these 3 things. First, squareness. On thick plates cut with lower-end plasma, you gotta watch out for an unwanted bevel instead of a nice, true 90-degree cut. Second, heat distortion. Remember that intense heat of an oxy-fuel flame? It can easily warp and deform thin carbon steel sheets. And third, kerf width. Always ensure your supplier has actually accounted for the physical width of the cut, that's the kerf, in their CAD drawings, which is absolutely vital for tight tolerance parts. Wow, okay, we've covered a ton of ground today, right? From the lightning-fast versatility of plasma to the heavy-duty, portable power of flame cutting. As you review your procurement strategies for this year, I really want to leave you with this provocative question to chew on. Which technology is secretly eating into your profit margins right now? Take a really hard look at your 2026 sourcing, evaluate your supplier's methods, and make absolutely sure you aren't losing money to the wrong metal cutting process. Thank you so much for joining me on this explainer, and hey, here's to a much more efficient, highly profitable supply chain.